In this video, we'll be looking at going the other direction. We'll be writing rules for sequences if we're given a few terms in that sequence. So let's jump right into an example. Write a possible explicit formula for the sequence 3, 6, 12, 24. Well, the first thing I notice when I look at this is that we are doubling the numbers every time. As we go from here to here, it's doubling, we go from here to here, it's doubling. So that seems to definitely be a pattern, which is really what sequences are. They're patterns of numbers. Well, that really means we're repeatedly multiplying by 2. And repeated multiplication, if I want to express that mathematically, is usually done with exponents. So that leads me to think this is probably going to be some kind of exponential rule. Specifically, because we're multiplying by 2 over and over again, we'll probably have a 2 to the n in there, right? 2 raised to some exponent. Now, we also know that we're starting with 3, so we're going to take this 3 and keep multiplying that by 2 over and over again. Well, this seems like a pretty good rule, but one thing we always want to do with these rules when we're making them is test them out, see if they actually work. Right? So if we think this is the rule for finding a sub n, then that means when we plug in 1, we should get 3, because a sub 1 is 3. Well, when we test this out, if you plug in 1, 2 to the 1, we get 3 times 2, which is 6, which that is not what we wanted to happen. Right, so this rule, even though it might be pretty close, is not actually what we want. Now, a common way to fix these, especially when you have exponential rules, is to just see, well, it looks like I multiplied by 2 too many times. So maybe my rule was actually not 3 times 2 to the n, maybe it's 3 times 2 to the n minus 1, because then, when I'm finding a sub 1, instead of it being 2 to the first, it will be 2 to the 1 minus 1, which is 0. 2 to the 0 is just 1, 3 times 1 is 3. So that one does work. And you can go and test this for the other terms as well. A sub 2 is 3 times 2 to the 2 minus 1 is 1. And then 3 times 2 is just 6. So that one works as well. And you could test the other two terms, they also work. Another example. Here we can see as we go from 5 to 8, and then from 8 to 11, and we're doing repeated addition. We're adding 3 over and over again. And mathematically, we express repeated addition as multiplication. So we want to keep doing 3 and adding 3 n times, right, over and over again. Now, if we look at this, we can also notice, oh, well, we're starting with 5, so we probably want to have a plus 5 in there, right? So we want to keep adding 3. The 3n is repeated adding. I want to keep adding 3 to 5. So let's test this out as our rule. Well, if we go ahead and test this out for a sub 1, you might have already noticed something's not going to work out, because we're going to get 3 times 1 plus 5, which is 8. So again, we're ahead of where we want to be. Right? It's close, but not quite. So we have a couple options here. One easy way to fix this is actually just to back up our kind of starting point, our 5, right? Because we know that we don't actually want to start with 5 and immediately add 3 to that, so we could change this 5 to a 2. Or another way to fix this, just like we did in the last example, is to say, well, I really want to add 3 one fewer time. Right? Both strategies will work for modifying this. So let's test this one out. A sub 1 now will give me 3 times 1 minus 1 is 0 plus 5. That gives us 5. So that one works. A sub 2 gives us 3 times 2 minus 1 is 1 plus 5. Well, 3 times 1 is 3, plus 5 is 8. that one works. And if you kept going, that would keep working out, and the rest of the terms would also work. One last thing I want to point out before I end this video is that, as you noticed in video 2, these two things that we just looked at are not the only types of explicit formulas. There are a lot of other explicit formulas actually. So when you're trying to write these rules, don't just consider these two options. You might have to get creative sometimes when you're making up your explicit formulas.